maybe Friday effect or whatever, but people didn't turn out. But I want to get started because it's already 10 minutes late. Okay, but let's get it going. Have you got a chance to play with yesterday's class at static partitioning versus dynamic partitioning? Have you tried that?
Mark, I have a question regarding that JSON structure thing. I tried that JSON stuff, and
Yeah, go ahead.
so when I like use that query as is, I remember we have array and structure and collection, and
Hmm.
when I use the query as is, I'm getting some error.
1 second, let's open that document.
Yeah, that T underscore employee or something.
You're talking about the second JSON table. Huh?
Yeah, T underscore employee.
Oh, T underscore employee should not give any error. That's a complex data type. Okay.
Yeah,
Okay, which query you're referring to?
yeah, that one just above one.
This one,
We
select
just
name,
passed.
address, or dot street.
No, the creation of the table. Just
Creation.
above that.
This
Just
one.
go before. Yes.
So create star table is giving you trouble.
Yes.
But I took the same one. An error.
You also got error, Midun?
No, Kumar. No, Kumar. I didn't get any error.
And Ravi, do you remember the error? What is the error it is showing?
Yeah, let me see if I can find out. Where is that? 1 sec. I'll just copy paste as is and it will come. So
Okay.
I think 1 sec. One
Okay,
sec.
so you get that. So in the interest of time, I'll just
Yeah.
proceed with the next one. Okay, so yesterday we were creating that plain table, right? A static table, and next step on that would be creating a dynamic table. So in that we create a staging schema. We'll use a staging schema, and we create a table, one-time table. It's a regular table, okay, not a partition table. This is a regular table with given columns, and then we load some data into the table. And just pay attention here, we can actually load compressed data also directly. Okay, it will actually accept the compressed data also. Okay,
Kum-
directly.
uh, Kumar, I just tried. Sorry.
Hmm, hmm,
I just tried and I tried in Hive and like Beeline.
hmm.
Hive it got created in Beeline. I'm getting an error stating that error in calling method execute statement. Whereas in Hive it just executed fine.
Error in calling statement.
Yeah, error in calling method execute statement.
Okay, let me execute in my system. Let's see.
Yeah, in Hive I just accidentally ran it in Hive and it got created. And I just dropped the table and tried the same thing in Beeline, giving that.
But the other day, I think we did it in Beeline only and it was working fine, right? When I created it, I think I
I
have
think so.
created it.
Yeah.
Uh, let me see. It might give me a problem saying that it already exists. So I'll create
Oh, yeah.
two.
Yeah, I think. For you, it seems like getting created.
It got created. Show tables. And if you see my employee and employee tables, you
Yeah.
connected to it, right? I mean, you connected using your credentials and all, right?
Yes, yes, yes. Like I'm able to do
Let me take
other
a look
queries
at
and
your
everything.
system then. Okay, I'm just
Sure,
making you presenter.
sure.
Okay, share your screen.
Yeah, sharing my screen. Like, yeah. So this is my Hive screen.
Hmm.
Are you able to see? So
Yeah,
I'm
yeah.
just create. Yeah, it got created.
Hmm.
So drop table. The same thing. I'm coming on to B line. Same copy paste. Oh, sorry. Where is that query?
Bad version in read message begin. I think there's a copy paste problem. So can you just recopy paste it?
I think I get. I suspect maybe got disconnected because it opened from the hibernate mode. One sec. Okay. And now I'm copying that query. Create table whole thing.
Hmm.
Paste.
One
Now
second.
it is giving something like.
Already exist. Drop it.
Oh yeah, yeah. It already exists. Okay.
Hmm. It got created.
Got created now. Got created. I don't know why. Like,
Hmm.
yeah, afternoon I struggled. It's all right. It seems like I don't know. I might have made some mistake.
Yeah, there could be some copy paste problem or something. Okay.
Yeah, yeah.
So
Okay.
yeah. So now let me move on. So here we have loaded the data into the plain table, and then we create another table, right? And this time, of course, it's going to be a partition table, as this column says, right? And then we execute this query. We set this dynamic partitioning equal to true, right? And then we set this partition mode is non-strict, and then insert override into this table. We specify the partition here, right? So here month and year and month is the partition that I'm specifying, whereas my data originally was coming as year, right? As long as my partition is year, I can very well go with static partitioning itself, right? But I want to create, I don't want to go with just static partition. Instead, I want to create dynamic partitioning. That's where we have specified partition year and month both in the braces, right? And here, of course, we'll go and query the table from the original staging table, and then it just goes and creates there. Okay. And similarly, yesterday, if you remember, we were talking about maybe I can just create these guys quickly, right? So let me go and create this guy. Okay, table got created. Then loading here, I think we have uh, what we have it here, batch 27 key under directly, right? Yeah, inside batch 27 we have 1987 is there, and we have 1996 is also there. Okay, and you go and load these two tables, load these two tables, load these two files into the table. Something is wrong. it is not accepting. Oh, I think it should be batch 27. Okay, it should be 27. And the other one also 27. So I have loaded some data into the table, right? Original table. And then I'll go and create another schema. Right? This is my actual schema. I'll use a schema and I'll create another table called partitioned table. Okay, so go and create that partitioned table.
So similar table with just the partition extra, right?
Correct, exactly. Okay, so here we just specified a partition, that's it, nothing more than that. Okay, now pay attention. Here still we are making it a stored as text file. Instead of making this guy stored as text file, these are all the possible options. Now, when to use these guys, what is the difference? We'll go there. Okay, just be with me. Let's finish the partitioning and we'll go to this file formats. Okay, and then you set this partitioning true and then fire your query. And remember, this query execution will take some time because it will scan that entire data there in the original table. It will segregate based on that year and month partitioning. It will put them into appropriate partitions. So it will actually take its own sweet amount of time. Okay, that's going to be a bit higher side time only because the entire data from the staging table has to be segregated into respective uh, year and month directories. Okay, so let's check that. User Hive warehouse. So if you see, this is our staging schema, right? So here you have the table. In the table there are two files directly, right? That's known expected behavior. Now if you go back to our actual schema, right? So here this is your table, and here there is still going on. That's why it is not showing you anything, right? It is still running, but once it runs, it will create year and month based partitions. Okay, you'll have year and month, year and month, year and month, multiple partitions. Right? I mean, of course, it
So when
takes
we are
time because it is having
Kumar,
enough data. Yeah.
so this is second. So the table with the partition, when we are creating like it, so did we specify? I mean, pointing to that select star from that other table.
See, creation time, there's nothing. We just created with this partitioning. Okay, but
Correct.
insert override, this is the key point, right? Insert override all this
Okay.
partitioning. So that's where it will just segregate based on that.
So insert overwrite and select. So we can even say star, right? All the columns, right?
Yeah, you can specify a star also.
Okay.
Okay. Now next one, right? I think we touch base at that. It will take time. Let it go on, right? It is taking its own sweet amount of time. It will actually take that significant time. But even in an office grade environment, that is expected because it's an intensive task. Okay. Now next one is bucketing stuff. So okay, I want to hear from you. We have discussed this yesterday while I was explaining my office use case. I was actually talking about that bucketed. So do you remember what is bucketed? When to use that bucketed? Bucketing example, we talked about it yesterday.
Yeah. So in our example, we talked about like instead of service date, if you are sending the file at the end of the month.
Right, exactly. So in case of partitioning based on some business criteria, there is a possibility of data skewness, right? Data skewness, which means you may have a a partition, another partition, yet another partition. Let's say this partition, right, at the end of the pipeline or end of the month, this partition had become larger, right? There is a possibility that this guy will become larger, right? Especially the month end guys, right? The month end guys will become larger and larger. So when it comes to the regular partitions, they will be smaller in size, and then there is a possibility that some of the partitions will be higher in size. This is what we call as data skewness. To avoid this data skewness, right, one can go for bucketing. So what we do it in bucketing is uh, we will have a hashing logic in place, right? We will have a hashing logic in place wherein you will define fixed number of fixed number of equal buckets. Let's say at the time of creating your bucketing table, you specify, let's say, 10 buckets, right? The incoming data will go into one of these buckets based on some criteria. I mean, it will just generate a hashing or something, right? So the incoming data will be routed to only these fixed number of buckets, and framework will ensure that the amount of data that goes into this bucket versus this bucket versus all the 10 buckets will be approximately equal. It will never ever happen that one bucket will be overloaded and another bucket will be underloaded. This bucketing, you can see the syntax. Okay, so here we'll specify clustered by and sorted by into 10. This clustered by is actually bucketing. So here we are bucketing it by unique carrier. So when you say unique carrier, let's say Delta Airlines goes into this. Okay, Lufthansa goes into this, right? Emirates goes into this. So whenever Emirate comes again next time, right? It will go to here only. Emirates will always go to here. Similarly, Delta always goes here. Similarly, Lufthansa always goes here. It will never ever happen that some records related to Lufthansa are here and some are here. That would never ever happen because of the hashing, right? So you will specify a column based on which the hashing would happen, and then based on that the data will be segregated. Now tomorrow you want to retrieve the data, right? I mean, that's the whole idea of we put the data into this. So tomorrow when you're retrieving the data, right, you will simply say get me the data related to Lufthansa, get me the data related to Delta, get me the data related to Emirates plus Lufthansa. So when you run the query, right, on that where class again, hashing will be computed. It knows in which bucket your data is there, so only those couple of buckets will be scanned through, and you will get the data faster than what is otherwise the case. It just goes to those buckets only. Of course, I mean, on what column you have to do the bucketing or on what column you have to do the partitioning always depends on the business logic, right? Your business requirement. So here, this example shows we are bucketing based on the unique carrier. Unique carrier is your one of the column, by the way, right? Unique carrier, your airline's company name, and it will be divided based on that, and then it will be divided into that many buckets. Okay, let me take a pause. Have you understood?
So, Kumar, so there is a good number of chance one particular bucket will be overloaded. If airlines related to particular are more, so that bucket will be overloaded. Right?
Correct.
Then how come it is equally divided into, I mean, the data is equally divided into all the 10 buckets?
Okay.
It is not a kind of a load balancer, right?
It's not a load balancer. Only thing is, assuming that you have enough data, I'm saying approximately equal. Okay, it can never be exactly equal because you'll have more data related to Lufthansa and less data related to, let's say, British Airlines, for example, right? But then
Okay.
How many unique carriers are there? How many air carriers are there in the world? Let's say 2000, for example, right? 2000.
Okay.
So it will actually happen in that you're dividing to only 10 buckets, which means 200 air carriers goes into this, 200 air carriers goes into this, 200 air carriers goes into this. Right now, let's say, hey, I'm going to do the bucketing into 200 buckets. If you do the bucketing into 200 buckets, right, then maybe 10 airlines goes into one bucket, another 10 airlines goes into another bucket, and so on and so forth. So the amount of data that goes into each of the bucket will be approximately equal, not exactly equal, but it will always try to maintain a balance among those given buckets. Now, who is going to do the this bucketing? Yes, your Hive is only going to do the bucketing. So here, right, we created this bucketing table, right? Here we are creating a bucketing table. Again, you have to do this insert override query. So as part of this insert override query only, the whole bucketing would actually work. So here you have to say Hive enforce bucketing equal to true, and then you have to run the insert override query. So when you run this insert override query, your data get divided into these buckets is going to happen. As part of this query only, bucketing will happen.
Then what's the difference between the bucketing and the dynamic partitioning? I can give the partitioning by airline when I'm creating a dynamic partition as well, right?
Yeah, true. But then the problem with that is if you have 200, 2000 air carriers, then you will end up having 2000 partitions, correct?
Yes.
And then one partition may have more data. For example, there is Air Costa, which is a recent airline. There will be a partition for
Hmm.
that guy, but then that will have very limited data. Whereas you take Emirates, that guy will have more and more data, right? So the whole idea of bucketing is to ensure that each of your partition or each of your bucket rather gets equal amount of data. And why would I bother about it, man? Even if it is not really uniformly distributed, let it go. Why would I really bother about it? Yeah, data skewness will always be a problem especially when you run a program on the entire data. The tasks which are going to get more amount of data will actually run for pretty long time. The other tasks also will have to endlessly wait for those first few guys to finish. Okay, so the data distribution, equally distributing the data is very important in a distributed computing environment, because even if one task is running, the entire job has to wait. So from that point of view, distributing the data load equally among a given number of partitions or buckets is actually important.
Kumar, just I want to confirm. So once the data is loaded, after that we do the staging operation. Then we'll do the bucketing, or it is a parallel process.
Bucketing is also stage based only, not parallel. It is you're right. Bucketing and dynamic partitioning both are stage based only. You have to load it into
Stage
some
based.
table, run query. That's the only way. And
So
once
after the data is loaded, then we need to do partitioning and the bucketing. Means like one by one.
no, one of those two. You don't need both. Either do partitioning or
Okay,
bucketing. One of these.
okay.
Kumar, one more question. So after bracketing, fixed number of
Yeah.
bracketings, can we change the numbers like addition or deletion,
Mother,
like
we can hear
reduce or
you.
increase the number? You can't hear me,
Are you
Kumar?
able to hear me?
Yes, yes. Even we can able to hear Malar as well.
Yeah.
We could hear.
I'm sorry. I think I got muted. I got my voice. Come again, Malar. I missed your question.
Can we increase or decrease brackets after some time?
No, that's not possible. Total number of buckets has to be fixed at the time of creating a table, and once you create the table, then it's not possible.
So then the alternate way would be like create a new table with the required buckets and then move the data.
Yeah, correct.
Ah,
Are we specifying the number of buckets
Yes,
at the time of creation of the table?
yes. So here is that into 10 buckets, right? So that number of
Oh,
buckets
into
is
10.
what you have
Okay.
to specify.
So we're specifying partitioned by as well as clustered by both of them.
Yeah, you can still specify that. Yes, partition, and it's your choice. Okay, you can have partitioning and clustering both, or only clustering. Your choice.
Okay. So,
Both
so when
are.
we say partition and cluster,
Huh.
so does it do like does it still gonna do partition by each year and month?
Yes, within that partition, it will be divided into 10 buckets. If you use
Oh, within the
both
partition. Okay.
within the partition, it will be divided into buckets.
Yeah, that will be like yeah, too many.
Too many, yeah, that will be too
Yeah,
many.
yeah.
Yeah,
So
but
ideally we should go for one of them, right?
it all depends. No, for example, if I say my partitioning is by state, for example, right? In state, I can have n number of things. So again, I'll go and bucket it by zip code, or I'll bucket it by some other criteria.
Okay.
So in this case,
Kumar,
going for bucketing and partitioning both may be overkill, but there are good number of examples where we might have to go for that combination.
Kumar Sandeep here. Just as Malar asked, like once let's say I have created 10 bucketing. Let's say in a given real-time example, today I'm getting 10 different source files, and I have used it with 10 bucketing. Let's say a new project came up and there are two other source files that I'm getting maybe from tomorrow or day after tomorrow.
Hmm.
Every time changing this and migrating the data into the new tables and new bucketing, is it feasible? Like,
No,
I have to change the entire code, right?
no, we need not to do that. I mean, the moment you say you create your table with 10 buckets, right? Even if you
Yeah.
get the next source, new source, the new source will be going into one of the existing bucket only. You don't have to really change that. Why do we change it? The existing
Oh, now
bucket.
now I get it. Yeah, maybe I have to map it to go the new source data into one of the 10 buckets.
It will be doing it automatically, because you will execute this insert override anyway on the staging data. So you don't have to do anything extra. You just have to say execute this insert override or insert table. You can remove the override that time, because you're talking about second time, right? So insert into the table, and then just go and run your query, and then your new sources will be routed to one of these 10 buckets, or two of those 10 buckets.
Okay. Can we configure that, or is it like inbuilt?
That's built in. You just have to run this insert override statement. That's it. You you
Okay.
you should not get into which source should go into which bucket. If you really want that, then go for partitioning, not for bucketing.
Got it.
Kumar, can you show the whole query? I mean that partition year comma month, how that is mapped to the staging table.
Okay.
Are we maintaining the same column?
See, this is the whole query.
So year and okay. So in the staging table we have year and month. So
Hmm.
it is exactly looking for the same name.
Yeah.
That's how it is being partitioned. Okay.
Correct. That's it. And here we have specified clustered by, right? Uh, I think I have got multiple examples. Okay, so this example is bucketing with no partitioning. Okay, so you see here, this is bucketing with no partitioning. So here there's no partition criteria here. We just say clustered by. That's it. Okay, bucketing only. There's no partitioning as such directly. Okay, and just notice here, I am giving stored as sequence file, not as a text file anymore. Now, what is the difference, Kumar? Yeah, there's a whole lot of difference. I want to show you that. So if you see in this guy is completed. Now, if you go back to our HDFS, right? Take a refresh. So here you have year and year, right? So segregated, and in the year you have months segregated, right? This is our year and month based partitioning. So now if you say get me the data related to 1996 January, only this subfolder, right? Only this subfolder data would be scanned and nothing else would be touched, right? So that in that way your queries are supposed to run faster, right? Because it will not be touching any other data. It will just go and pull the data only from this particular guy. Okay, and but if you look at this data is still in plain text format only, because there we have used the option as text file. Okay, but instead of using the text file, if you can go and use any of these files, any of these formats rather, right? So if you use any format other than text file, right, it will be compressed, so human readability will be lost, right? But it is actually recommended to use one of those formats rather than text file. Why is it so, Kumar? Why shall we do that way? Yeah, because these formats are recommended because they stores the data in a compressed format, and they have been optimized to retrieve the data quite faster than the text data. And the there is something called splittability. I'll talk about that. Those formats are splittable. As a result of it, we will be able to get parallelism. Okay, whereas the text file, it's good because we will still have human readability of the data would still be there in the HDFS. But the problem with the text file is it's not really optimized. It's not really uh, performant, right? It's not really that performant. Whereas the other formats are really performant. Okay, so let's before going to the formats, right? Is this a bucketing with partitioning, bucketing without partitioning? Is it clear? Right? This is the query. This is the query where we are using only bucketing, no partitioning. The next one, bucketed plus partitioned, both are there. Okay, so are you with me? Let me try running this query, but this query, this bucketing will take even more time. Okay, and actually, this stored as sequence file might create a trouble for us. Let's try this. Okay, database does not exist. Huh? I think I have to change it to 26. Okay, airline 26. Do this total. Hmm. Okay, it will take significant amount of time. Let it go, because you see here we have stored it as sequence file, right? That takes more time because it will do the compress. It compresses the data, so it'll take more time than the regular text file. But it occupies a very less amount of space on the HDFS. Okay, because it is a compressed format. It occupies very less amount of time, and there might be a possibility that it may get into out of memories also. Let's see how it goes. Okay, uh, after this plain bucketed do partitioning, then next example is a bucketed plus partitioned, right? So where here we are specifying partition by as well as clustered by, right? So in this year, in this month, each of the data will be divided into this many buckets, further subdivision basically. Okay. Any other questions? Uh, can't we store in XML format? Uh, you can store it in XML format also, but there's no, I mean, XML format is not a, what do you call, format type. These are the Hive supported formats. Okay, you can't specify storage as XML. No, but you can load XML data directly. Okay, you can load XML data directly, and the XML data can be stored in one of these formats. Okay, I mean, you can still load your XML data, but that internally will be stored in one of these formats, either text or RC or ORC or Parquet or Avro or sequence. But these are the only formats that can go here. So stored as, right? After stored as one of these six will go here. XML will cannot come. But of course, using your Survey, right? XML Survey, you can still load the XML data, which we have seen, right? That is still possible.
Uh, Kumar,
Yeah.
just a silly question, maybe. Is the partitioning and bucketing is it right to say it's applicable only for internal tables? Is it can
Why
also be on external or it's only
it can
internal
be
tables?
on it can be on external also. Why it should be restricted to internal only?
I mean, like if the data is already existing on HDFS, does if we define a partitioning and bucketing, does it alter the existing HDFS dataset? By the way of I mentioned partitioning and bucketing, it will reorganize the data.
A external table it will reorganize. Uh, in the table here in the insert statement anyway it is going to recreate that.
Okay.
It's going to recreate it, right? I mean, your staging table would not be touched, but then the actual table would be always new data will be created, no?
A new copy of. Okay.
New copy of it, yeah. Okay, so this query, see here, this query is still running as expected. But if you go and uh, check the table with what name we have given, yeah, bucketed no partition, right? Bucketed no partition. It is still running. That's why you can't see. But then once it gets created, if you look at the data, it will be in binary format. You can't understand what the data is. It will be in a binary format. Okay. All right. So now moving on to the next one, right? So the next important concept is this formats, right? So when to use which format and what are the pros and cons of each of them? Again an extremely important concept to understand. Okay. So text file is good for learning and experimental purpose, but not many people in the industry use this text file. Okay, it's only good for learning purpose. In a typical office grade environment, we use one of these guys. Okay, out of these guys, this RC and ORC. Okay, RC stands for row column format, row columnar format. Okay, row columnar format, RC format. And this ORC is optimized row columnar format. So nowadays, not many people are using RC again. RC is gone. That has been replaced with ORC. So people will use either ORC or Parquet or Avro or sequence file. Okay, Kumar, still we are left with four. So which one to use when? Yeah, it is generally recommended to use these two guys when you have your data to be in a non-changing schema. If your schema won't change frequently, right, then better you go for these two guys. Whereas if your schema changes frequently, go for arrow. If your data is non-text data, image file, audio file, video file, something like that, go for sequence file. Okay, so static schema, text oriented data, go for parquet file or ORC file. Schema changes dynamically every now and then. If your schema is changing, you'll have to alter the table and add more columns on the fly. Then go for arrow. And binary data, you go for sequence file. Okay, now there are two where we are talking about non-changing static schema. So when to use which one? First of all, what is this row columnar format, right? Why there is something called row columnar format, and you are saying they are going to give you good performance boost. So how will they really give me performance boost, right? So to understand this, we will have to go and understand the concept of row columns. Okay, so let me introduce you that row columnar format with an example. Okay, let's switch back to our favorite example of telecom. Right, it will be easy to explain there. So if you go and load this data into a table in Hive, right, in a plain text-oriented format, which is the default, it will be stored like this, correct? And if you want to read, let's say if you want to read as per the business problem that whatever we had, correct? We say get me a mobile number and average call total duration, right? So how system will do behind the screens is it will read this data, I mean read this row, take out the mobile number, take out the duration, again go to next line, read this, take out the duration, again read this, take out the duration, right? Take out this guy, take out the duration, and so on and so forth. So if you have, let's say, 100 million records, so it will scan through 100 million lines, right? And it will read that mobile number and duration, and then it loads it all into that memory, right, or into disk, whatever. But it goes through each and every line. It extract the required columns, and then it do a group by operation, right? That's quite cumbersome. Okay, now what this row columnar format says is, okay, you transpose your data. So if you take this guy, right, transpose your data. Now this guy will come, okay, plus symbol is there, okay, comma, this guy will come next, okay. Like this, your row will become column. Okay, now this will become one row. Now next one, this guy. Are you getting what am I trying to convey? So in this way, right? Now your row will become column, a column will become row, right? Then next two guys also would be like that. And then next one is my duration, which is 973 colon 368 colon 82 colon 849 colon 29. So now what is the advantage, Kumar? Yeah, now the advantage is system, when it scans, it just scan this record and this record. That's it. Remaining guys, whatever are there in between, it need not to scan. So you're now, even though you, let's say you have 50 columns, So here we have taken only six columns, but if you take say 50 columns, right, and you will end up reading only two records, and this entire data will be read, and it just does the semicolon separation. It takes all of them. Similarly, the next column it does that, and then it will be much faster than scanning each of these record and then extracting those only required columns. Right, your data scanning now is minimized to only some data, not to the entire data. This is what is the fundamental concept of row columnar format. Okay, row columnar format, and both these guys, Parquet and ORC, are actually this row columnar formats both. Okay, let me take a pause. Have you understood this? Any questions on it?
So does Hive support row columnar format?
Hmm.
I mean, so far we are defining the tables in a typical normal way,
Correct.
like Oracle.
So far that was the case. Okay, so if you see this guy, sequence file got created. Okay, now next one, what we can do is here, instead of sequence file, you say ORC. Here we have used a sequence. Where is that? This guy, right? So use ORC, and
So
here
automatically it will take care of
ORC. Yeah, that's
conversion.
it. Yeah, nothing else. Okay, now go and do this.
Kumar, can you just explain me the advantage of this one, Kumar? I think I didn't get it.
Okay, the advantage is if you go with a normal one, right? If you go with a text file, let's say you have records of like this up to 100 million, for example, 100 million records. Okay, your row count starts from one and it will go all the way to 100 million. Okay, now you want to do that telecom example, right? So you want to say mobile number wise call total duration. So when you say mobile number wise call total duration, how system will do the things behind the screen? It'll read this line, right? I mean each and every
Yeah.
line from that 100 million.
Yeah.
It'll extract this
Particularly, yeah.
guy and this guy, right?
Mm.
Likewise, the all the records it will scan through, and it'll extract the required records, and then it does that group by operation followed by some operation. Correct? Correct, Malar?
Yeah, yeah, getting it, Kumar. Yeah.
Yeah. On the other hand, if you say you want to go and use ORC, right? If you want to say ORC, when you are loading this, right, here you are inserting overwriting. So here if you see, you are saying after this you say uh, oh, I think I have made a little mistake, guys. So here I have to use this name, right? So here insert overwrite into this name, right? I have to use this name only, right? So when you say insert overwrite into this, my data now will be converted into this transposed form. It will be converted
Okay.
into the transposed form. Now, the moment it converts into the transposed form, let me kill this job, okay? Because there's no point in running. One second, I'll do that. Yarn kill hyphen application ID. Even if you stop it here, right, it runs behind the screens. Okay, so we have to kill it. Then only it will be stopped. Yarn mm, syntax. I missed the syntax. Yarn kill hyphen killer yarn yarn hyphen kill, I guess.
Are you trying to kill the beeline or?
I'm trying to kill that application. The application that we just started accidentally, I forgot to give the actual table. Instead, I have given some other table, right? Yarn application hyphen
Okay.
kill. Okay. Yarn application hyphen kill. Yarn application hyphen kill, and then the application ID.
So each query is treated as an application ID?
Hmm. Yeah. So if you see, it is telling you clearly, no, job. When you run this, it is saying starting job. Then this is the application ID, which means it's going to be a map reduce job.
Oh, okay, okay.
Okay,
So the
so this
job
is
is
all.
nothing but application ID. Okay.
Yeah, and then oh, it came out of Beeline also. Yeah, when I pressed that Control C, I think it came out of Beeline. Uh, the table is there, I think that's not an issue. So I just have to run this guy again. So you say connect JDBC colon hive 2 colon slash slash quick start dot cloudera colon 10,000 batch 27. Something is wrong. What happened? Oh, hive 2, right? I have to give hive 2 cloudera show tables, and you use this hey, where is that no partition? Oh, okay. I think it was not in the no partition, so it is in the different schema. That's cool. That's fine. Right. So now here I am specifying my ORC table. Right. So at the time of creating the table, anyway, I specified my format as ORC. So my data now will be loaded into this ORC table, right? Into this ORC table in a this row transposed manner, right? This regular data, and we are taking the airline data also the same thing, right? So here whatever data that you have, unwrap it. Okay, so whatever this data you have, that it just will be transposed. Okay, row transposed. Now what is the advantage? Yeah, now Malar, back to your question, right? So the advantage now is your column become a row now, right? This column had become a row now. That's why we call it as the row columnar format. Now what is the advantage? Yeah, now my advantage is when I run the query, select average of duration from mobile number, group by mobile number, right? It need not to touch these records. It just read this record, read that row, and read this row. That's it. It doesn't have to touch any other record. Only two rows it will
Got
scan
it.
through. Is
Okay.
that
And
clear?
then number of rows also will be like limited to 5 or 6
That will be equal to your number of columns in the original
columns.
data
Yeah,
set.
yeah, yeah, yeah. Okay.
So,
I understood.
okay, yeah. In the
Kumo-
query, if you are selecting 10 columns out of the 100 columns, it will be the scanning will be now restricted to only those 10 columns or 10 rows rather.
Kumar, every time you're running the query, you're giving the bucketing is equal to true. Do
Hmm.
we have to do that every time?
Uh, you can do that every time, or you can make it permanent also in Hive.
Okay.
You can make it permanent one time also.
So Kumar, so just trying to look at the distinction between row columnar versus normal. So now we could see the advantage of row columnar. So then when should we go for the normal typical rows and columns? So is it something when we need to work on individual records, like I want to know for the line ending with 0 to 7 what is the average, and the line ending with 745. So when should I go for the normal
See,
structure?
normal one, um, normal one is not really good for not really good for requirements where you have 100 records and you have a requirement of frequently querying couple of them, a subset of the 100. If you have to run your queries on all 100 records, then going for a RCA or Parquet will not really help you,
Okay.
right? Are you
If you
getting?
need to retrieve all of them.
Yeah, if you have to process your entire table, I mean, you don't have a specific business use case of selecting, let's say, 10 columns out of 100 columns, then if you, that is a situation where your Parquet or ORC will help you. If you have a requirement where I have 100 columns and I will be accessing all the 100 columns always, then ORC and RC might not really help you, right?
Okay.
Are you getting?
Yeah, yeah.
But in a typical office grade environment, that will be seldom the case, right? We will load the data and we will read some columns. We will not read all the columns always.
Correct, correct.
We won't do that select star always, right? So that's where
Right, right.
RC and ORC or Parquet, and I mean, sorry, RC people are not using, you can safely forget that, but ORC and Parquet are the ones that are frequently being used in the industry.
So in your production grade environment, most of the time you're using columnar stuff only, right?
Yeah, we are using Parquet. All our warehouse tables are actually Parquet tables.
Oh, okay.
Okay, now Kumar, there is ORC and Parquet. Both are, you're saying both are similar. So when to use which one out of those two, right? When to use this guy versus when to use this guy. Both are row columnar. Both are compressed. Both are splittable. Both are good for higher performance. Uh, but then when to use which one out of these two? Yeah, sorry. So we go for ORC when you want to retrieve a group of columns always together. Okay, it will do some optimization internally. So if you want to retrieve, let's say there is a table. Let's say there's a table which is related to employee profile, or maybe there's a table related to your clickstream navigation data. So when you say clickstream navigation data, you let's say you have columns like on what page the user had clicked, what is the IP address, what is the browser he had used, what time the click came, right? How much time you had spent on that particular page. So some data would be there. If your underlying application always want to access those 10 columns together. Many a times, if you take the case of employee data, for example, say deductions, right? Your deduction, how much is the federal deduction, how much is the state deduction, how much is the insurance, right? These three things always accessed together, right? Similarly, let's say you take address case, right? Address, you'll have street, you'll have zip code and your state and zip code, right? They'll always be accessed together. So if you have that group of columns always accessed together, if that is what is the underlying table requirement, then going for ORC will give you a better performance, because for the grouping it will do a better optimization. Whereas Parquet is the case where you don't have such grouping enabled, then you go for Parquet. If you don't need that kind of grouping as per your business requirement, better you go for Parquet. Whereas if you have a grouping, then ORC will give you a better performance because it does some optimization internally when it comes to those grouping. So basically, when it stores, right, when it stores this column and this column we are talking about now, right? This column and this column always accesses together. Then it does some internal optimization to further boost up the performance. Are you getting, or is it confusing, friends? Now these are really advanced concepts, okay? Really advanced concepts, and many people in the industry doesn't know. Many people who are working on Hive doesn't know. Believe me.
Kumar, can you just tell us like what is that internal optimization, like any algorithm it uses, like just briefly, if not detail?
Well, yeah, I mean, it does this, it combines these two rows, right? It does the combine those rows, and it does what kind of algorithm, I also don't know, but it just groups these columns together so that when you access them together, the disk hits would be reduced and then it will read the data faster than what is otherwise the case. But the algorithm details, I also don't know.
Okay, okay, Kumar.
So it should take care of separation also, right? Yeah. So let's say phone number 243 is associated with so on. So phone number 114 is associated because these are all kind of semicolon separated. So each of them should be mapped to the appropriate other row.
Yeah, they always goes with the position. Okay, I mean, if in one of the row, if this guy is not there, there should be like this. Two separators will consecutively. I mean, null should be coming. That's extremely important because it goes with position only. This positioning is important, right?
Okay.
All right. Okay, so we are running short on time also.
So DynamoDB
7:40.
is more of this one only, right? Dynamo
Uh,
and Cassandra.
sorry.
Dynamo and Cassandra are databases. They're all columnized databases, right?
That is different actually. Uh, Dynamo, Cassandra, HBase, they are NoSQL or column oriented databases. This is row column. Okay, conceptually similar, actually speaking. Conceptually similar. Yeah, I mean, that is something similar actually. But you have more flexibility there in that row columnar format. Everything and anything and everything will be in this columnar format only. You can't even store anything in a regular format. Only columnar format is what this Cassandra Dynamo will do.
Okay, okay.
Okay. Yeah, these are all files, Mukesh. Yes, these are all files, of course. Internally, everything would be file. So if you see this guy failed actually, my query, right? My ORC actually failed. It would have given you out of memory exception if I'm not wrong. If you take the log file of this guy, right? Let me check the log file of this guy. Yarn logs hyphen application ID. Oh, sorry. I think I have to do this in the yarn prompt, Unix prompt. Okay. So there is something went wrong that query didn't run. So let's check what went wrong. True. Hmm. The segments with so left. New decompressor snappy. Okay, let's go to job browser and check that. There is something went wrong. No, it was mostly, if I'm not wrong, that is a memory related error. Go there. What was the job ID? Job ID was 84. So go to 84. This guy. So check the log files. Click the full log file and check for error.
Is it the yarn screen?
Sorry.
Is it the yarn screen?
This
Like
is yarn
slider.
screen. Yeah, this is yarn log file screen. Yeah, you see here it is saying Java heap, right? Java heap space. I told you, right? I mean, it is actually very intensive task. It takes that into memory and then it will compress that. It will try to convert these rows into columns, right? Convert the rows into columns, and then it tries to compress that. That time, very high amount of memory would be required, and it gives you Java heap memory. And we used to face these things in Office cluster also. Okay, it's a very common problem. So the only way is we have to increase the container memory. Do you remember we talked about the container memory, right? So we have to increase the container memory and rerun that. That's the only way, because you are transposing the entire data, which is quite complex task. But one time overhead of creating the tables, but from then onwards, performance wise, business will be very happy, right? If you the developers will have to face the struggle of loading the data, but once the data is loaded successfully, business will be happy because it will run quite faster. When it comes to running the queries, it will run quite faster. Okay, so we'll stop it here, friends. It's already 8:46. So we'll continue tomorrow, not tomorrow, sorry, Monday. And this weekend we are going to have classes. Okay, and scoop class will be there. You just follow the regular time only. Tomorrow regular time. No, regular time. Can we make it 1 hour before the regular time? Because it has to be a long class. Okay, so 1 hour before the regular time. Is that all okay?
Sure, Kumari.
Sure.
Yeah,
6:30 India time.
6:30 India time. Yeah. So you can use the regular meeting ID itself. I will inform Mahesh, right? And Sunday, let the Java class continue. Okay.
Kumar, can you confirm we have Sunday Java class?
I will ask Brahma. Okay, I'll write an email to Brahma and Mahesh both. Okay,
Okay.
I'll plan. I'll inform them. I'll ask them to
Okay. Okay.
inform you rather. Okay.
Okay, Kumar. Okay.
All right, friends. Any other questions?
I have. So regarding JSON, that Saturday jar file,
Uh-huh.
like I tried to download it, I'm getting only the source code. I could not find the jar file. And from the source code, when I try to generate the file, I'm running into
You
some
you you
error.
take this from here. My G drive. It is there in our G
Oh, okay,
drive.
okay,
Right,
okay.
you have this JSON Saturday.
Oh, okay, okay. I didn't see that. Cool.
Okay, type in your email ID, Mukesh. Type in your email ID. All right, friends, sure. Thank you. Yeah, I got your email ID, Mukesh. So I'll add that. Okay, bye bye.